Okay, hopefully everybody can hear me. Okay, so today we're going to talk about Milestone 2. So Milestone 2 is about interactively visualizing a map. So it's more open-ended than Milestone 1 was. The specification is loose. There are certain required features that you have to do, but there are some other things where, and exactly how you achieve those is more up to you. So we're going to teach you the basics of graphics, data structures, we've already taught you about, and using OSM data. But to get the best solutions, you're going to have to come up with some of your own ideas. So there's room for some innovation, some creativity in this one, as well as some basic features. It's different than what you have in most of your labs, maybe not all, but in prior courses, most of your labs are relatively closed end. What I mean by that is, you go in, you follow the instructions, you apply the course material, and it'll work. And when you're doing design, you still do that. You apply what you've learned in class or elsewhere, but the idea is that you should be able to go beyond that if you want to get the best solution. So that's kind of what we're looking for in Milestone 2. You can apply what we told you here, you'll get a basic solution. There's some room to go further, if you have the desire and you have the time. Okay, so let me give you a few words of caution, though. Basically, because Milestone 2 is a bit more open-ended, it's good to start early and apply the agile development method. So get something working, improve it. It's much lower stress. It's also more effective. You're constantly improving rather than trying to build a whole bunch of stuff all at once and then testing it all. So test as you go along, improve, iterate. And don't try to be perfect. Don't try to do everything. Most projects throughout your career, you're going to run out of time on. That's just the way engineering works. You keep improving until you run out of time, or it's just there's not enough value to improving things. That's true of this milestone as well. You are not going to hit a point where you go, I can't think of anything else I could do. There will be more things you can think of. Doesn't mean you should actually do those things. So what we want you to be in this course, this is a curve that you can see the reference below. That is basically how much are you learning as a function of pressure. Okay, so performance in this case is how much are you learning, how much are you getting done. So if pressure is really low, it's just really easy, it's tedious, you're just doing the same thing over and over again, you're bored. So this actually label says bore out. And in fact, if that happens in your career or your education, you're at risk of just kind of stopping. You're not going to learn that much. And you might even get so bored, you just say, I quit my job or I stopped my degree. So we don't want to be there, where you're just doing the same thing over and over again. You want to actually feel a certain amount of pressure. Oh, this is a bit challenging. I have to kind of bring my A game for this. And maybe feel a little pressure, but you're not very worried. That's not bad. Okay, you will learn a reasonable amount in that point. This next portion of the curve where the pressure is a little higher, so maybe you're doing something that you haven't done very much before, it seems a little more open-ended, a little more challenging. It's called you're in the stretch zone, okay? So we use these terms all the time in companies like stretch goals, stretch tasks. And you're actually learning, you're a little more stressed because it's a little more vague how you're going to do on this, but you're actually learning a lot. So if I look at my own career, the times when I learned a lot is when I felt a bit stressed because I'm doing things I haven't done before. Starting a company, making a computer chip, etc. The very first time I did each of those things, it was stressful, but I was at points in my career where I was learning at a very rapid rate. So I'm kind of in this zone. Now, if the pressure gets too high, then you start actually, you're stressed out and you're actually learning less. You're obviously also not enjoying yourself as much. So we don't want to put you here, okay? And we definitely don't want the stress to be so high that you're actually at risk of burning out. That's true in your education. It's actually, again, true in your job. So good managers watch for this. They watch for people who are, the tasks are so simple, they're bored, they're not really doing the most they could, or they're so hard or so stressful that they're up in this range. Okay, so if you think you're up in this range, come talk to Dr. Tallman or I. And this is not the goal. So the fact that this is open-ended does not mean we expect you to go off and do everything you can think of, and otherwise things are terrible. That's way too much pressure. Take a step back, think, am I here? I'm challenging myself some, but I still feel good about it overall. And there'll be periods where things aren't working in your career or any assignment you do. So there'll be, you might have brief spurts up here where you go, nothing's working, I'm stressed out. As long as you can get back pretty quickly because you go, okay, I got it working, fine. All right, so that's a long way of saying, don't put too much pressure on yourself. We do not expect perfection. Perfection is not achievable on a more open-ended task like this. You have to figure out how much work you want to put in, how much makes sense given your other demands in your education and life. So any questions on that? I basically do not want to get a bunch of emails from like the 231 instructors saying all the students are like spending all their time on 297. It's like, I swear to you, I am not telling them to do that. I'm actually telling them not to do that. So you heard it from me, don't do that, okay? Don't leave it to the last 2 days though either. So you don't take a big assignment that you've got a long time to do and say, I'll just leave it to the last 2 days, we'll see how it goes. Might go okay, it's a very high risk strategy. You're gonna be in this zone, really stressed out for a shorter period of time, you will not learn as much. Not a good way to do things. Okay, so that's kind of a meta discussion. And as I say, it applies to your whole career. Whenever in my career I found myself, I was getting too comfortable. I was doing the same kind of related tasks too many times. I would quit my job or change some part of my career after a while because I would get bored. But I didn't want to do that for me, I don't want to do that every year or two because then I'm too stressed out, right? I want to do it every once in a while, so I stay kind of in this zone. Okay, so let's go into a little more concrete things about Milestone 2. So Milestone 2, you have multiple API levels, which you've conveniently already been learning in Milestone 1. So remember, we have 2 layers of interface to this OpenStreetMap data. We have this libstreets database, or streets database API.h that talks about streets and street segments and intersections, and that's what you used mostly in Milestone 1. And then we have this lower level API, this OSM database.h, which gives you even more data, some of which is not available in this upper level API. Okay, so for Milestone 2, you have to use the data in Streets Database API, and you're pretty much going to use all of it. Okay, you're going to visualize streets, you're going to show their names, you're going to be able to show somehow whether they're one way or not. You're going to show us points of interest like Tim Hortons and gas stations. And you're going to show us features like parks and buildings and so on. So you're going to make use of pretty much all the data there. And the good news is for Milestone 1, you basically know how to access that data. Okay, so what about this other one, OSM database API.h? Once again, that's all the OpenStreetMap data. So there's even more there than in that Streets database higher level API. It's less structured, so it takes a little more investigation of how do I use all this data. And you've got to start on this for Milestone 1 because you wrote one function that used this, find the latitude and longitude of an OSM node. You can optionally use this, but you don't have to, okay? So you can complete all the required features that we ask in Milestone 1 or Milestone 2 without using this API at all. If you want to, though, you can use it to put additional detail on your map, and we'll count that as extra features. We're asking that you come up with some things of your own. Anything you take out of this API would be considered extra. So one example would be subways. You notice in the Streets database API that you're probably pretty familiar with right now, there are no subways. That data is in this lower level OpenStreetMap data, and so you can pull it out and you can use it. If you want to figure out how you can use that data, we wrote a quick start guide to get you going. You read that, it actually gives an example of how to get started with subways. And then it also points you at the OpenStreetMap documentation to learn more. And you'll have to do some experimentation if you choose to take data out of this, because as I said, it's less structured. So you need to do a little bit of investigation of how is this data organized. Okay, so basic requirements for Milestone 2. You need to visualize streets, features. So again, features are like buildings, parks, lakes, that kind of stuff. Points of interest. Points of interest are just points on the map like Tim Hortons and gas stations. So you need to visualize all of that stuff, and you can get it all from Streets database API.h. You need to be able to, we want to see that you can actually handle user input as well. So you need to be able to, when a person clicks the mouse, show some information about that intersection. So you'll interpret that as you've selected an intersection, which one have you selected, tell me something about it. We also want you to be able to find intersections by name. So person types in the name of a couple streets and you say, okay, here's the intersection between them, show some information, highlight it. And you'll notice that what we had to do in Milestone 1 is going to be helpful for this. So you're not going to necessarily you won't use every function you wrote in Milestone 1, but some of the functions you wrote are going to be really useful. So don't just forget them. Don't put them out of your mind. They're helpful to you in completing Milestone 2. We want you to be able to load any map without recompilation. So what that means is your TA is going to have you demo your program and say, okay, show me Toronto, okay, show me Moscow, show me Beijing. You don't want to say, oh, okay, let me go in and edit the source code and recompile, because some end user of your, let's assume that you had a mapping application on your computer that someone else had made, and if you wanted to go load a different city or look at a different part of the country, you had to go edit the source code and recompile it. You probably wouldn't be super impressed. So your TA doesn't want to see that. But don't say exactly how you select a new map. You can choose. It just can't involve, recompiling the program. Your graphics should be fast and interactive. And this is actually probably the biggest challenge. There's a lot of data in representing one of these cities, and we want you to be able to show us these details, like what's a one-way street, what are the names of streets, and so on. But at the same time, we don't want, when you're zoomed way out, to be just overwhelmed. And you have either just a big black blob, or the map is incredibly slow. So this is a challenge. So we want, part of how you're going to deal with that challenge is level of detail modeling. So partly you want to write good code, so your map is fast, but that's not going to be enough. You also have to decide how much detail should you display. So maybe you have buttons that turn on and off some detail. Maybe you adjust it as people zoom in and out. But somehow you want to make your map stay fast and present the appropriate amount of detail. So people can figure out the details when they're really looking for them. But if they want the big picture, they're not overwhelmed by all sorts of irrelevant information that are clutter up your display. So there's going to be some cleverness to that, and some creativity and aesthetics. We're going to test you on a bunch of maps. So a lot of my examples up here, I'll just use Toronto, but we're not going to just test you on Toronto, so don't hard code things. Your TA is going to run your mapper during grading. So your mapper, that's your actual executable, okay? And we didn't use your actual executable in Milestone 1, but we will in Milestone 2. We also have unit tests though. So ECU 297 exercise is still useful. It will run a bunch of cities through your graphics. So you can just click on it, and it's one way that you can quickly check, do you work with a whole bunch of different cities that your TA is likely to test. And it will also take a small map, St. Helena, and have your program draw it while it runs it through Valgrind. So that's useful for checking for memory faults. And that is the one unit test we will run, okay, when we're grading it, to make sure you don't have any Valgrind errors. So you should run ECU 297 exercise, but you do have to have this main program. That's the main thing that TA is graded. So what does this mean in terms of where you write your code? You write a little bit in main/source, because that code gets turned into your mapper executable. We've given you a skeleton for that code, so you don't actually have to add a lot to it. You can change anything you want, but you don't actually have to make a lot of changes. The main thing that that's going to do is it's going to call this draw map function, which actually visualizes the map and lets the user interact with it. And the bulk of your code, you're going to write once again in libstreetmap/source, because that gets turned into your libstreetmap library, which our unit tests can interact with, and your main program, the mapper program, can interact with. So that's where you're actually going to write this draw map function. You're not going to write one giant function, okay? If any of your teammates try to do that, like I want to write a 1,000-line function, don't do that. So draw map is, the top level routine. You're going to have a whole bunch of helper functions, okay? Keep your functions short in here. Okay, grading. I know that Probably this is of limited interest because everyone's doing this just for the pure intellectual challenge. But in case anyone is curious about the grading scheme, we have created one. There's a detailed rubric. So go on Quarkus and you can look at that. And your TA is going to fill that out. So it's in your best interest to go look at that rubric in advance rather than having it be a surprise when you get your mark back. In brief, this is worth 15% of your final mark. Code style and project management is worth 2. So just like Milestone 1, how did you do things? What does your code look like? Basic features, which are listed in the instructions and on the rubric. So, drawing streets, being able to label them with their names, etc., is worth 5 marks. Responsiveness, usability, aesthetics. So does your map look good? Is it fast? Is it easy to use? And some challenges here, let me give you a sample challenge, is you want to display the street names well. And that's actually surprisingly tricky. So you have these streets, you got to decide where to label them and how to label them. How many times do you label a street? How zoomed in are you before you start putting labels on these streets? Where exactly do you put them? You'd like to line them up with curved streets. So this can be done pretty nicely, or it could be done fairly crudely. So your TA is going to look at that. And then the last 4 marks are extra features. So extra features are just stuff you come up with. So we give you some ideas in the handout. You come up with your own ideas. So some ideas are you might display some extra data from that lower level API. So for example, subways. I already told you that's not in the upper level data, so you might go and do that. You might make more interaction. So we say you have to be able to click on an intersection and get information. You might make it that you can click on all sorts of stuff and get information. You can get data from the web. So we've written a libc URL is a library that allows C and C++ programs to talk to the web. So you can go read this quick start guide that shows you how can you go get information off the web. So you could use that to do all sorts of things. Bring in live traffic updates, get information on, say there's Tim Hortons, you could go get the reviews for that Tim Hortons, whatever you want, and many other things. Again, we give you some ideas in the handout. Don't try to do them all. So your TA basically is, if you don't do any extra features, like you do nothing beyond the basics that we ask you for, then you won't get any marks for this. So it's not the end of the world. You lose 4% of your final mark in the course. But it's not going to kill you. If you do, 1 extra feature and it's really nice, then your TA could be quite impressed by that. If you do a couple of extra features that are both kind of interesting, your TA could be quite impressed by that. Don't look at this list and say, oh, I listed 3 things here and there are another 5 listed in the instructions. You must do 8 extra features, okay? Because it's too much. The 231 profs are for sure going to be contacting me. Don't do it, all right? So kind of set your goals reasonably. It's also why you, again, try to do this, try to get going early, because it's a lot more fun, a lot less stressful if you get something going and then think about how much more do you want to add to it. Oh, actually, and one more thing I should add here is you can just make your user interface nicer. So I'm going to show you in the rest of this lecture the graphics library that we've written for you in this course, which is quite easy to use. Another source of extra features is if you basically just add things into the graphical interface, different dialogue boxes, different ways of interacting with the program. Those are also extra features. Okay, so I'm going to quickly, so any questions on that so far? Okay, so if not, I'm going to demonstrate what our solution looks like. Yeah. So say it really loud, and then that's even better than me turning on. I don't actually know how to turn on the, there's something weird with the display here, so I do not know how to turn on your mic right now. So just say it super loud.
So how many small features equivalent to a big feature?
So I'm gonna have to come closer. I can't quite hear you. So you have to say it louder. Or...
So how many small features work for a big feature? And by small, that means the size of complex.
Oh, so like, what makes a complicated feature versus a simple one? Is that what you're asking?
Yeah. So how many simple features?
I don't have a perfect number for you, right? So basically, you talk to your TA. Your TA kind of looks at how well this overall map works. If you do a complicated feature, then one complicated extra feature is fine, right? Your TA page thing, tell me more about that, you know. Yeah, depends how simple your expertise are. If they're very simple, I'm going to show you an example of not very good special feature. You might need a lot like that. And it's still might not be. So probably, have 2 or 3 medium ones. Make your TA pretty happy with one hard one. If they're super simple, then your TA might go, hey, I'm trying to begin with all. Does that answer your question?
Hey, Vaughn, can you hear me? Maybe not.
I could hear you, Ken.
I can't hear you right now. Are you saying anything to the
I
class?
wasn't talking. Setting something
Okay.
up.
Okay, gotcha.
So I'm just going to show you the teaching team's reference solution. So we make a solution for this as well, so we can feel your pain, make sure everything's good. So this is our reference solution. I'm just going to ask you, you can grade it. You can see how we did. Okay, so here we are. We've got a bunch of buttons on the left-hand side or the right-hand side. Some of these I'm not going to show you yet because they're about visualizing algorithms for the later milestones. But I can basically, zoom in, I can zoom out, I can grab the map and drag it around. So I do all that stuff. I can hit zoom fit and it goes back. None of that's very hard. The graphics library basically does it for me. I can show, parks and lakes and roads. I'm showing actually the major highways when I'm zoomed out, so that seems kind of good. I have some controls for detail levels. Right now I said details off. I can click that, and now there's way more detail. And I'm zooming in. You see a bunch of streets. You start seeing buildings, etc. And let's see. You can see. This is okay. So what do you think for aesthetics? There's like a point of interest here. You can see the outline of a building, and this looks like it's the something alternative school, I think. What do you think of my aesthetics of how I displayed this point of interest name? Kind of got the font size a bit wrong. Okay, like I'm having trouble seeing this, so not the best for aesthetics on that. I'm going to zoom back out a bit. Let's see, I've got names off. So I got a control button here. I turn names on. I'm going to zoom in again. And now I've got street names, which are hard to read. But what do you think of my street labeling? So I just turned on street labels. If I zoom out enough, they turn off. So all the street labels are gone. I zoom in, street labels come back. They're those little red boxes. What do you think of my street labels? Are they good? Somebody's got to have an opinion. Is this like all you ever hoped for? I see you shaking your head. So C11, what's wrong with my labels? Yeah, actually, even with me putting my eyes right up against the screen, I can't really read them. We got the font size wrong. We're kind of annoying. Like we show some street names right now, and then we zoom out, and they all disappear. So not very sophisticated in terms of deciding how many street names to show. And this, just drawing a red box and putting the name of a street in it kind of somewhere near the street doesn't seem very intuitive. So not great from a street name labeling perspective. We didn't do very well on that. Let me just do a zoom fit again. Okay, so let me turn off this excessive details. I can turn on and off the kind of natural features. Looks much better when they're on. And I'm gonna just drag this over and zoom in again. So I'm zooming in. You can actually start to see the redraws at certain points. Okay? So the redraws are actually, there's a lag. So when I'm zoomed out, it seems reasonably responsive. When I zoom in, it seems a bit laggy. Okay, so you can kind of see that redrawing, but it's a bit laggy. So I would say, from a usability and aesthetics point of view, not a disaster, right? We hit the major features on this, but we could have done better. You can definitely see room for improvement in responsiveness and how usable our interface is. Let's see. We do have a special feature here, or an extra feature, so subways. So I just clicked on that, it drew the subway lines. Okay, zoom in a little, you can see the names of the subway. So I do have a special feature. Okay, hit proceed. It's going to end my program. So what do you think? How do you like the reference solution the teaching team made? Thumbs up, thumbs down, kind of sideways. See people going, whatever. Yeah, it's kind of so-so. We didn't actually focus primarily on usability or the graphics. We wanted it as a reference solution. So you can do better than this. It's not terrible. It's not the worst. It's not the best. So it gives you maybe some idea of what to shoot for. I said that you should be able to run a different map without recompilation. So our solution for that is command line options. So I just asked for help. Our program prints out help. So, and I can basically tell out the name of a map. So it defaults to Toronto, but I can change it to something else if I want. So let's change it to New York, for example. Okay, now it's going to bring up New York. Okay, oops, I thought I brought up New York. Let's see what I just did there. Okay, so it's getting worse, right? My grade's going down. Maybe I should have stopped what was ahead. Let's see, what was my last command? Oh, I forgot the option. Okay, so I didn't read my own help very well. Okay, so that should bring up New York now. Okay, that looks more like New York. Okay, so it's maybe not the most elegant way to change maps. I have to actually exit the program and run it again, but it does satisfy the requirement of I didn't have to recompile. Some students go, they don't know what I mean by not recompiling. So what I just showed you, I didn't recompile. So you might do something more elegant. Maybe it'd be nicer to have a button in the GUI that allows you to just load different maps. That would be considered an extra nice feature, right? What I showed you meets the basic requirements. And again, I can show all the subways for New York. I can zoom in, I can see, eventually these are going to get labels so I can see what their names are and so on. And you can see, my aesthetics are not great, right? I zoom in, my subway stations are enormous, but the labels on them are tiny. The labels on my points of interest are tiny. So maybe some fine tuning for aesthetics that we could do here. All right. So let me go back. So, okay, so our map did actually have an extra feature, subways, which is not a bad one. It means that we had to dig into the OSM data and organize it. Here's another extra feature that I proposed. Dr. Tallman's not too nuts about it. I want to change the color scheme. Okay, so I'm going to have a pinkify button. Okay, so here's the map normally. You click on the pinkify button and it gets more pink. Okay, and here's the really special part. You click on it again, it gets more pink still. So you just keep making it more and more pink the more times you click on it. So what do you think? Is this a good special feature? Dr. Tallman's not too convinced, but I think it's awesome. I tested it with my youngest daughter and she loved it, right? So we did some usability testing. Yeah, what do you think?
Yeah, I think it's a really good idea, especially for colorblind people.
Okay, yeah.
Good feature if your target audience is colorblind.
Yeah, and that could be something you do, is choosing a good color scheme for colorblind people. Now, I didn't actually test this on any colorblind people. I tested this on my 11-year-old daughter, okay? So, yeah.
I don't think this is a good feature. From usability side, I don't think it has too much of the actual use unless most comes from research also. And for difficulty side, I think it's only altering the draw channel or change the red channel of the draw. So more red on that.
Right.
That is artifact. So
Okay, so I'm just going to summarize that since I just now figured out how to turn the mics on again. So yeah, it's not a great special feature. So if you want to make this, it's fine, but it's not going to get you a whole lot of marks. We haven't justified like why would you do this very well. Like it's not clear why a pinkify button is useful. And secondly, it's pretty easy. Okay, I basically just change. I have a bunch of colors and I can load in one of two sets of colors. That's actually not very much code. Your TA knows it. So you can do it, but this wouldn't be a super exciting special feature. Hopefully, if this is the ones you do, you make some other ones as well. Okay, so difficulty matters. Okay, let me talk briefly about how this links to WD1. Okay, so if you can quiet down back there, I really don't want to be talking over people here. And guys, I'm going to turn your mic on, and then you're going to be on the line for everybody, okay? So how does this relate to WD1? So you're starting a new project. You're starting Milestone 2. And when you do that, you should make a proposal. That's what you're doing in written document 1. And written document 1 consists of multiple parts, basically surveying the landscape. So you're doing background research on what are a few examples of GISs, but more deeply, how do other people make them responsive and make them usable, like easy to use? So get lots of detailed information across without overwhelming people. What makes their user interfaces intuitive, and how fast do they have to be to feel responsive? So those are some of the questions you're trying to answer as you do this background research. Okay, as Dr. Tallman talked about on Monday, use credible research, things that you believe and your reader will believe. Then you're going to make a plan. So what are you going to do? And link it to that background research. How are you going to use some of these ideas you saw in the background research? Or maybe there's some ideas you don't think are very good. So you're going to explicitly not use those ideas. You're going to use certain other ones. And how will you measure success? So a part of WD1 is to write down your goals and your testing. And maybe the background research gives you some ideas here. Okay? And just a repeat of don't skip this step of surveying the landscape. Sometimes people make that mistake. We're forcing you to do it in this course because you have to do it for WD1. But in your career, when you start a new project, you always want to do some background reading to make sure you're not reinventing the wheel. Okay, so take a couple of minutes. I'll put up a timer. Talk with the people around you if there are anybody around you. If not, just find somebody nearby. How are you going to measure these things? We intentionally asked for things that are a bit vague. Usability and responsiveness. In WD1, you're supposed to come up with some ideas. Well, what are those and how are you going to make them good? So you've got to turn that into some concrete targets, as concrete as you can, in order to have tests and say whether you met it or not. So take a couple of minutes, discuss with someone around you. What are you going to do? What does this mean? How are we going to test for it?
So I have a question.
So I don't have too much to say on
So
it.
for this, they can go straight to ArcGIS and just start.
They could go look at it, yeah. So, okay, so I figured out how to use the mics again, I think. I'm gonna clear everybody in the queue in case you pushed it by accident. Anybody want to share ideas they had on how are we gonna make this concrete? So usability and responsiveness sound a bit vague. How to make that concrete? Any ideas? Let's see. Okay, actually, still not using this well. So D07, you're on the line, and let me make sure you've got. Okay, let's turn that off. Let's turn that off. Yeah, go ahead. Yeah.
Okay, so one thing you can do is if there are any buttons or anything that requires any modification, you can find the ones that you like say a button press of like a redraw or surface or
Okay.
or something, and you add all on your face.
So that's on responsiveness. So time it. Is that right? And that makes sense. How will you know what's good enough? Makes sense to time it. Well, how will you know is this good enough or not good enough? So it's a trick question. So yeah, C05. Let me actually hit your button. I'm going to turn on your mic if I can. Okay, let's see. Okay, your mic should be on.
Yeah. Okay. From just one I'm very concept before that's not good. So I need to usually should be waiting for balance to work.
Okay, so you're saying timing is good, so you just have to wait. And I guess I'm trying to see, well, this is where background research comes in, right? I don't actually know the answer either of what's, you could say make it as fast as possible. Okay, that could be a soft goal. But in terms of have you made it good enough or not, it's hard to say. This is where background research can be useful. Is your problem of how fast does a program have to respond before people consider it annoying is not a unique problem. People have done research on this. You can go read about it and leverage it. So time is a good way to do this, and basically read the literature. Whoops. Oops. Let's see what is going on here. Okay. That's all I'm going to write on that one. So let's go to any ideas on usability. How will you measure usability? So A07, I'm going to go to you. So let's clear that one. All right, and speak nice and loudly.
The definition of usability is something usable without being tricky. So we are going to do it properly back down spend 1 minute and the after the there and I'm going to perform a certain action on the research. General, probably just comparing with the log to the real
Okay, so you said watch what people do, try to estimate their effort versus using other maps. Is that correct? Yeah, so this is usability is a difficult thing to measure because it's fundamentally, yeah, do people find it usable? And that's a bit of a vague question, but this is a reasonable answer. Watch what people do and then compare them to using other maps. How do you compare them? That's still a little vague. When you say compare them, what does that mean? Do you ask them which one do you like better? Do you time them? What do you do?
There can be several ways to do that. For example, we can have their actions we want to do it. Also, we have some people administer the action and see the result and the verification. Like for example, practice actions also. I think we do some research about how people react to that and research and how to get the background.
Okay, so yeah, a couple of ideas in there. Sorry, my pen is not working, so that's why I'm trying to make it work again while we're talking. but I'm not going to write any notes because I think the batteries just went. So some good ideas in there. You could bring people in, have them try it, ask them what they thought. A little better than that, in my opinion, is the second thing you said, which is time them. Giving them tasks and timing how long it takes is a fairly objective way to measure usability. Sometimes people will measure how many things they have to click on or data entry. It's not bad. You have to click on 20 things. That's more annoying than 2. Timing it is probably even better because you just see how long does it take. We did this when I was at Altera. We'd bring people in to use Cordis, and we'd actually put a camera. I mean, I didn't personally do this, but the user interface people would put a camera in the room, and they just let the people use it, and they'd watch what they did, so they could actually see where they're confused, and they time how long it takes. And you actually do that with, typically for usability testing, you do it with 2 groups of users. Ones who are not experts, so they've never seen it before. How long does it take them to figure it out? So they just give up. They try to use it for a while, and after 20 minutes, they just go, I can't take it anymore. Can you let me out of this room? That'd be really bad. And expert users, because expert users can be different. They already know the interface. How fast are they once they know all the buttons work? So these are some of the ways that you could choose to make these goals concrete. Okay, so some of what we just talked about for responsiveness is timing things. Try to make your program faster. And let me put this back here. How do we do that? So how can we time how long it takes your program to redraw the screen? That's kind of your most important responsiveness. So you can sit there with a watch, but if your program's pretty fast, that might be difficult. So what else can we do? So any thoughts? How are you going to time things? Because one of the comments was, let's try to time how long it takes for your program to do something. So what do you think? So let's go A07. I think you're still online.
There are 2 ways. Either track how much the user amount of action that for example, per second, which is maximum user articles, or maybe that's a time binding option, which I would do like a option, so that time will be about
Okay, yeah, so I couldn't catch all of that, but I think basically said you can measure the frames per second by redrawing many times and seeing how long that took. That's one way you could do this. You could wrap a loop around your redraw function to the point where it takes long enough to, they say, do 100 redraws. Then you could actually take a stopwatch and see what happens. But even better is you can actually have programs time themselves. So I'm going to give you a little bit of timing code. So this draw main canvas is going to be a major function. You're going to have a redraw function for your screen. That's your most important speed limiting function for this milestone. Doesn't have to be called this, but let's say we called it that. In that function, I want to time how long it takes for this whole function to execute. So there's a library called Chrono as part of the C++ standard. And basically I can get a start time from it with a little bit of code that I've written here. I can go draw all sorts of stuff. And then I can go get the time again with the little bit of code I've written down below. And this library is the syntax is a little baroque, but basically I subtract those 2 times and I cast them to get a number in seconds. These are basically 2 objects. I subtract them, I say convert it to seconds, and I print that out. So if you take this little bit of code and just wrap it around your redraw function, you can now measure its speed. So I don't expect you to remember all that syntax. It's in the slides, so you can go look at it after. Okay, so I'm going to go very quickly into an intro to graphics. I'm not going to get through all this. We'll talk about it after reading week. I posted all the slides, so you can see this in advance, so you can get going on Milestone 2. Okay, so graphics APIs. You have a program, and it wants to draw on the screen. So, and we want to be able to draw on different kinds of computers. It could be Windows computers, Linux computers, printers that typically use PostScript. All of those they're basically different. The way you actually get at the hardware is different in each of those. So we could write pixels for our screen or for a paper, for a printer, directly into the hardware. And that's what you did in ECU241. ECU241, you had a VGA display and you wrote straight to the pixels and they showed up on the screen. What do you think? Do you want to do this for this course? Anybody want to do that? Okay, nobody seems to want to do that. And yeah, that's not a good idea. Why is this not a good idea? So it's fine in 241. You did it in 241, so you learned how to talk to the hardware. Somebody's got to do it. And actually, some of those people are going to be computer engineers. So good thing to learn. But now that you've learned it, I'm saying don't do it in this assignment. Why not? So any idea, what are the problems with doing this? So let's see if there's anybody else who hasn't spoken yet. I want to see, I'm going to clear everybody. And so click your microphone if you wanted to say something you've never gone to. I'm only going to give you about 5 seconds because we've got to keep moving on. Okay? All right, so I'm going to tell you then. So there are a bunch, it's low level, so it's a lot of work. Okay, you want to draw circles and squares and polygons. You're going to have to write all that code. So that's a lot. It's also going to be different on every platform. So the hardware is different on Windows, Linux, PostScript, even different from one Windows computer to the next. So you're going to be writing this code over and over again. And then the last thing is that you have many programs sharing the screen in a modern computer. So the operating system will not allow you to write pixels directly to the screen. It'll actually kill your program if you try to do that because you're a security risk. You're in a shared environment. You're not allowed to do that. So you don't do that. What you do instead is we're going to use a graphics API, an application programming interface that talks to the hardware for you. And usually you want to use what's called a cross-platform API, one that works on multiple kinds of computers. So it's higher level, so it's just function calls, easier to work with. You can write your program faster. It can target different hardware. So the person who wrote that library, or people who wrote that library, had to implement those functions, multiple times, so they work for different hardware, but they've already done that. And the operating system trusts it. So part of that graphics API, at some level, there are device drivers. Device drivers are special bits of code that are allowed to access the hardware, and the operating system won't kill them. So it can do what you can't. So there are a lot of different graphics APIs out there. We're going to use a graphics API that we actually wrote for this course called EasyGL. It's basically simple, so you can. It's pretty fast to get going on. It provides a lot of functionality for you, and you have to use that in this course. Okay. That graphics library is itself layered on top of a lower level graphics library called GTK, which is used to build a bunch of applications, particularly on Linux. So some of the applications using in the lab are written using GTK. You can go and use GTK directly if you want. Okay, we give you a little bit of information about that. You don't have to do that. Probably 60% of the students in the course will not do that. They'll just talk to EasyGL. That's fine. But if you go, well, what other features are available? Are there some clever, search bars and dialog boxes that I could use? Yes, they're in GTK. You can go use them if you want, but you don't have to. They'd be considered an extra feature if you do any of that. GTK itself makes use of even lower level APIs, specifically one called Cairo and another called X11 that are actually low-level rendering APIs to go on the screen. So there's multiple levels of interface. You have to talk to EasyGL. We give you all the source code for EasyGL. So if you want to, you can change anything you want in it. And you can also call GTK directly if you want. But you don't have to. As I said, probably 60% of the students will not make any changes to EasyGL and will never look at GTK. So that's totally fine if that's what you want to do. Okay, let's see. And I think we can, well, maybe I will just tell you this so you can get going on Milestone 2. My strong advice is do not leave Milestone 2 too late. So you've got several lab periods. Don't waste the first few lab periods and weeks just waiting. Get going. How do you get going? You type this command, ECE297 and init2. It's going to add the EasyGL code into your Git repo. The reason we add this code in instead of just putting it in the public directory is that you can change it if you want, but you don't have to. You are going to read an example application and the quick start guide that we put on Quirkus. Easiest way to going EasyGL is quickly read the first part of the quick start guide and then run the example application. Look at how it works. That's a really good form of documentation, is just to look at an example. And in any file where you're going to want to make graphics calls, you're going to include these two headers at the top. EasyGL is heavily commented, so if you go into those header files or you just use an IDE, you'll see, what functions are available to me. So that's kind of your library of what can I do. Okay, and I think that's where I'm going to leave it for today. As I said, I'm posting the slides now, so you can read ahead if you like, because you may want to do some work on this in your lab period. And if you feel like it, you can do some on over the next couple of weeks. Don't leave it to the end. Thanks.
Hey, Vaughn, so maybe I'll stop my recording now. Yeah.
Well, I think I forgot to record, Ken, so you might have the only recording.
Okay, I will stop it right now.